Okay, this is our part 2, second video. So we're going to continue our module 2. Now in this video, we're going to look into the negations, additions, subtractions, multiplication, and also divisions. For fixed number arithmetic, in these sections, we're going to look into a common arithmetic functions on numbers in two's complement or second complements. On negations, what is basically negations? In two's complement notification, the negations of integer can be formed with the following rules. First, take Boolean complements of each bits of integer, including sign number, each set 0 to 1 and each 0 to 1. This one is like normal first complements. And treating the result as unsigned binary integer, add with 1. So it's going to be second complement, which is we're going to add with 1. So example, those two-step process is referred to two's complement operation by taking the two's complements of an integer. So example, for 18, which is plus, which is positive 18. So we have 18, if let's say from decimal to binary, we will get 16, 0, 0, 1, 0. This is basically the value of 18, because we assume it is to be 8 bits. For second complement of what we're going to do is, first we're going to apply 0 to 1, 1 to 0, 0 to 1, 1 to 0, 0 to 1, 1 to 0. So this will be the first complement normally in this first. But before this, like in our previous subtopic, you know, and similar also to your digital logic subject, you know that your second complement only apply into second complement and first complement only apply when you have negative number. But under negations, we will use the second complement notification. So any like sign number, we will assume it to be unsigned binary and integer. So that's why we will change 0 to 1, 1 to 0, 0 to 1, 1 to 0. And after we use the first method, we need to add with 1. So same to this second step, similar to your second complement. So that is going to be your answer. And normally you will notice that when you apply this, it's similar to negative 18 for second complement. Normally, as I mentioned, second complement, first complement apply into negative numbers. So this one is negative 18, so equal to this similar part, two's complement. So what is happen when you have like a bitwise complement, bitwise complement? So what is basically bitwise complement? You notice that after this you going to change back. When you apply back, this one second complement, right? When you apply similar things to negative numbers. This one is our negative 18, you can see. Then you apply back the first complement method, 0 to 1, 1 to 0, 1 to 0, 1 to 0, 0 to 1, 1 to 0, 1 to 0, 1 to 0. You will get first complement, and second complement you will add with 1. You will get your second complement, but this second complement for positive number will be negative number, and second complement for negative number we will get positive number. So this is just to show you between these two complement you're going to get a vice versa value. Not value, sign. Value is similar, which is magnitude, but in terms of the sign it's going to be vice versa. Okay, this table I already shows you the value. This is recap. 0 plus 0 you get 0 as the sum. 0 plus 1 you will get 1 as a sum. 1 plus 0 you will get 1 as a sum. All is carry 0, but when you have 1 plus 1 you will get sum as 0 and carry as 1. This one I already shows you that, right? So adding the numbers into complement, so that's why you need to convert into second complement. But of course you can see this one, it is positive number, the value is similar, although it is second complement. You can see we need to apply positive only, no need for us to change to second complement, because you're going to get negative 5 if you use the similar second complement. The only things that you need to change is negative value. Similar, positive is nothing happen. You not need you to change, because this is already proof you that when you do the second complement it's going to be vice versa, right? This is second complement for 7. You can try it, how to convert. This one is very simple. Okay, when you have second complement as mentioned, you're going to discharge the carry. Remember again in previous video, if you have carry for first complement, what you need to do, you need to carry forward. If for second complement, if you have carry, what you're going to do is you're going to discharge. So that is different things. So that's why if you have a carry, going to discharge. So you can see also there is a possibility as mentioned, if you add like positive number, negative number, you're going to also have a possibility to have overflow or an error. So let's take a look into subtraction. Subtraction is easy to handle with the following rules. This one you already also learned in your digital logic, which is when you have any numbers, which is A, let's say, you need to subtract, tolak, right? You're going to subtract with any number. So let's say this is a variables only, whatever variables. What you're going to do, it is equivalent to A plus negative B. So that's why this one you can apply the second complement. So when you apply the second complement here for negative number, you're just using the simple additions. Although previously in your first question, It is subtraction, but you change it to be additions by changing the value of p. So this is the things. Example here, let's say you have 2 minus 7 equivalent to 2 plus minus 7, and let's we convert it. This one we will get 0 0 1 0 plus negative 7. First we will convert it into a binary. We will get 4 2 1 0. This is the value of 7, negative 7. Then we need to convert to second complement, right? So let's convert it first. 1 0 0 0, and this is our first complement, and second complement it will be 0 0 0 1. So let's take a look. This is our negative 7 because we apply the second complement for negative 7 negative numbers. So there we will add negative 7 1 0 0 1. So this is our answer, which is negative 5. Negative 5, how are you going to define it as a negative 5? It is a supposedly you can see over here it is negative, but is it correct or not? You can see, wait, okay, you can see you get negative 5. This one is sign, but this is the value of you can see if you directly get, you're going to get what is this, 2 and 1 3. But of course this one is our second complement method, and for this part there is a possibility of error. You can see there is a carry, that's why you're going to like discharge it. So this is your answer, 3. And for this part you can try also whether you get it correct or not. Then you can see there is like several numbers that you have an overflow, although you are using the representations. Subtraction can be done directly also with the rules. No need for you to change to the additions. So you need to know, if you have 0 minus 0 you will get 0, 0 minus 1 you get 1, 1 minus 0 you will get 1, 1 minus 1 equal to 0. But if you deduct or subtract from lower value rather than after that you need to like deduct or subtract with the higher value, what you need to do, you need to borrow 1 from the next most significant. This is a normal mathematical. Let's say we have 37 minus 17. We directly convert it, 37 and 17. We divide 1 minus 1, we will get 0. 0 minus 0, we will get 0. 1 minus 0, we will get 1. 0 minus 0 is 0. 0 minus 1, you can see this part. So we will get 1, but we will lend from beside here. So it will be 0 and 1 will be borrow here. That's why you will get 1. It is not 1 minus 1. Okay, it is not 1 minus 1, but you check first. Okay, this one is 0 minus 1. So 0 minus 1, you will get 1 first, and then after that you borrow. If you borrow first, it seems like 1 minus 1. Then you will pick a wrong answer. So what you need to do first, for the case of 0 minus 1, you need to put directly the answer first, the sum first, then you bring the borrow. The rest is 0 minus 0, you will get 0. Okay, there is an example exercise here. You can try to do it. So I guess it's quite easy because it is like rarely similar to digital logic subject. Okay, under multiplication. Multiplication is so complex. You can try to read it. But you can see multiplication of binary must always 0 and 1. So there is no like 2, 3 and etc. Although it is a multiplication. So there is also a table for you to remember on the multiplication. Last time we have the table of additions. Let's take a look into the table. Okay, this is additions, and then we have subtraction. 0 minus 0. Okay, so this is our subtraction table. And now we have multiplication. We have another tables for multiplication. 0 plus 0, multiple with 0, you're going to get 0. 0 times 1, you get 0. 1 times 0, you get 0. 1 times 1, we got 1. You can see whatever number you times with 0, you will get 0. And no carry or borrow bit for a multiplication. So let's take a look. If let's say you have a multiplication, it's divided into unsigned integer and signed integer. First, we're going to look into the unsigned integer. So we will divide it into several, which is we call as multiplicand and multiplier. So where is multiplier and where is multiplicand? You can see this is our multiplicand, which is the numbers that we want to multiply with the multiplier, and the answer will be a product. Simple, right? So let's say you have this binary number, you're going to multiply. Okay, there is example, but let me go through one by one. 0, 1, 1, 1. We're going to multiply with 1, 1, 0, 1. So of course we're going to like multiple the right side first, right? This is normal mathematical. So 1 times 1, you get 1. 1 times 1, you get 1. 0 times 1, you will get 0. 1 times 1, you get 1. Second part will get always 0 because it is 0. So next is 1. You get similar things. Sorry. How to delete? Let me delete first, so then you're not going to confuse. why cannot delete? I delete all. Sorry. Okay, let me try to do it again. 1011. No need for us to see this first, okay? We go like very manual things from mathematical. 1 plus 1 you get 1, 1 plus 1 you get 1, 0 you get 0. So second part we will get all 0, and third and fourth. So this is, we add a normal mathematical also. 1 0 plus 1 we get 1. 1 plus 1 plus 1 plus 1 we will get 1 carry 1. 1 plus 0 plus 0 plus 1 we get 0 carry 1. 1 plus 1 we will get 0 carry 1, and 1 plus 1 we will get 0 carry 1 also. So let's check our answer over here. It's totally similar. So you can see, if we ignore the sign bits, the length of multiplier is an n bits multipliers and m bits for multiplicants, and for n and m for multiplier is a product that is n plus m long. So you can see we have 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. So that is our answer. You can see your multiplicants, multiplier, you add together you get 8 for product, and that will be your bit long. So please try to change this value. Let's say you change it into 0011, 1010, and try to do the multiply. Okay. Now you can see there is a multiplicand, but it is a signed number. So this part, it is unsigned. So you directly like use the numbers that given. But when you apply with the sign number, as I mentioned, sign number, which is of course a negative or positive. For negative part, normally you're going to apply their second complement. We have seen the additions and subtraction, previous slide, can be performed on two's complements notations by treating them as unsigned integer. After we apply the second complement, if this number are considered to be unsigned integer, then we are adding 9 plus 3. 9 plus 3 to get the 12. So this is a positive numbers and this is unsigned. But as a second complement or third complement integer, we are adding minus 7, which is this part, to 30011 to get minus 4. How we get minus 7? Of course, you just need to convert it by doing first 0 to 1, 1 to 0, you will get, and then after that you will add 1 as a second complement, you will get, so this value will be your answer, which is 7. But because this is a second complement, you know that it's going to be a negative value. Now, unfortunately, this simple scheme will not work for multiplication, especially for the two's complement. You can see the answer. Let's say you like directly multiply them together, which is negative and negative number. although this one is the second complement for each of these numbers, but when you apply directly to multiplications, your answer will be wrong for the product. This example demonstrates straightforward multiplication cannot work or will not work if the multiplicand and multiplier are negative. So there is a limitation. So limitation for the multiplications method, which is you cannot directly apply the second complement and direct apply the multiplication if both number is negative. So that is the only limitation for now. Regular multiplication clearly yield incorrect result. So what is the solution? The solution will be multiplications algorithm. This multiplication algorithm is very important. This is new for you. Before this, like first complement, second complement, it's all like a recap things you learn from digital logic subject. But multiplication algorithm is new. So you need to remember step by step. So there is several steps you need to know step by step for multiplication algorithm. Later on, you will also have the division algorithm, but first we look into multiplication algorithm. You can see a multiplication algorithm and hardware. Multiplication must cope with overflow because we frequently want 32-bit products as a result of multiplying two 32-bit numbers. Okay, you can try to read it, but this is the flow. How basically you're going to apply into your multiplication hardware in your ALU. But I guess there is no need for you to remember everything. There is no question like that to memorize all the thing, but the step is very important. This is the must. You need to remember this flow diagram. Flow chart you need to remember. You need to start. After that, you're going to test the multiplier with 0. When you multiply with 0, your answer is 1 or 0. So it's going to divide it. If 1, what you're going to know, what we're going to do. If 0, you're going to direct, shift, and multiply, register left 1 bit. You repeat again, and then is it 32-bit repetition or not? If yes, you're going to done. If no, you're going to continue. Let's see what is basically all these mentions. As long as first of all you need to remember, second you need to know the step. Right, example here you have 2 times 3. Multiply, you're going to define which one is your multiplier, which one is your multiplicand. So this is multiplicand, this is your multiplier, this is your product. So you have 0, 0, 1, 0, 0, 0, 1, 1. First step, you're going to test the multiplier. Where is your multiplier? This is your multiplier. You need to test whether it is 0 or 1. If 1, then you need to do this answer. If 0, then there is no operation. After that, you shift left, and then shift right. So later on I show you all this step, okay? Maximum bits number of iteration based on 7-bit numbering system use. Okay, let's take a look. First step, you need to draw all the value. This is the value of 3. This is the value of your 2. You can see multiplicand, multiplier, multiplicand, multiplier, product. Okay, this is your product. First of all, you're going to put 0, 0, 0, 0. Then, first, what you need to see? You need to see whether your multiplier 0 or 1. You can see, this is your multiplier. You need to see the test multiplier 0. What is 0? Is bit 0, whether the value is 0 or 1. Example, if you have 0, 1, 0, 1, this is your multiplier 0 bit. So what is the value? This is 1. So you need to do here. If you have 0, 0, 0, 0, what is the value of the multiplier of 0 bit? It is 0. So you're going to go here. Okay. So let's check. Now we have multiplier. So the bit 0 is 1. So because it's 1, what we need to do? We need to add multiplicands to products and place the result to the product result. Multiplicand. This is multiplicand. You need to add with product and put here. MC plus P equal to P. This one P, right? So let's take a look in proper way. P equal to P plus MC. Because of bit 0 of our multiplier is 1. And you're going to get 0, 0, 0, 0, 0, 0, 1, 0. This one you add together. Next, what you will do? You will do shift the multiplicand register left 1 bit. Okay, shift MC left 1 bit sekali je, which is 1 time only. Our MC, this one. So we're going to move it. This part, right? We move in front, we move in front, we move in front, we move in front. What our answer will be? What is the end? It will be 0 because nothing happened here. So you're going to move, move, move to the left. Stop until here. The next step, shift the MP to the right. So I'm going to shift, 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 okay? To the right 1 time only. So I will get 1, 0, 0, 0. I shift here, so nothing happened, it's lost. So shift here is going to be 1, and then shift 0, and I add another 0 in front because there is no value need to add. Cannot add 1. To complete 4, we will get 0, 0, 0, 1. That is the first cycle. You can see that it's going to ask you how many repetition. If the question asks you about 32 bits, so you need to repeat 32 times. But now we look into the question, we look into 4 bit, right? So we need to repeat like 4 times. Okay, let's take a look. You can see, is it already repeat 1 time or not? Sorry, a 4 time or not? Not yet. So what we need to do, we're going to go to up here again, because it is no 4 bits. If let's say 16 bit, 8 bits, it depend on your questions. Okay, now you can see here. Next, you're going to bring it up, and what you need to check, the last bit of your MP. Still it is 1. Oh, because it's 1, what you need to do, you need to add P with MC. So you add now the value of our P with our MC. When we add, we're going to get 0, 0, 0, 0, 0, 1, 1, 0. So let's take a look. Correct, right? Then second step, shift MC to the left. So from here we will get 0, 0, 0, 0, 1, 0, 0, 0. MP to the right, 0, 0, 0, this one, so it will be 0. Stop here. We will continue because it is only 1 time, 2 times. It is not 4 yet. So second time we will like go back. You need to refer to the flow chart. Go back to the up, and you need to check the bit 0. Now it is 0, so no need for you to do the IA. 1A, no need for you to do 1A. You need to directly to shift left. Shift left over here, you will get 0, 0, 0, 1, 0, 0, 0, 0. And for your MP, you just get 0, 0, 0. Now you still also have like a 0 over here. Let me remove. Over here is still 0 because it is only 3 times. What you need to do, you're going to repeat several things, which is there is no operation. And here going to see shift MC to the left. So I'm going to shift 0, 0, 1, 0, 0, 0, 0, 0. Shift to the right, MP 0, 0, 0, 0. So my last answer, you will check, oh, it's already 4 bits, so we're going to end. So what is the answer? This is my answer, the last one, because after that there is no more. So this is my answer, which is total as a 5. So please try to do different value and try and apply into this table, because it's important. You're going to be asked in your test. Either it is a multiplication or divisions. 5, right? 6. 4 add with 2, you will get 6. Sorry, not 5. Okay, now you have like we have 5 multiplications of 5 with 4 using first versions of hard recommended hardware. This one is the method name, right? Where is it? This one is the method name for this part. So now let's take a look at the example. Okay, what is our value? Multiplier and multiplications. Multiplier will be I forgot already. Last semester, I give this as assignment for you. Please try to do it, and later, I will share you. Basically, I'm going to upload also this example solution for 2.2. I already upload into YouTube last semester. I will share with all of you also. Please apply. Where is your multiplier? Where is your multiplication value here? What is your product? And try to do it all. Okay. So I guess before our end of our class, or maybe I will ask you to upload your works. Later I inform you in our class, okay? So after you watch this video, please directly do the solution of 2.2, because I'm going to ask you to submit, or maybe you need to share your works in our class. Then I will share you the video, because this one I already shared the video last semester. Basically it's similar. Okay, now you can see also the multiplier MP must always positive number. This is a rules that you need to remember. Okay, our MP here, you can see multiplier is always negative. So check whether there is a negative number or not. If not, it's lucky for you. You can like putting everywhere. Both is similar. But if you are playing around with negative and positive number, you need to always careful. MP only apply for positive number. Do an additive inverse to multiplicand's MC and the MP. So you can see over here, multiplicand's multiply with negative multiplier. So you have the reverse one, negative multiplicand, because multiplier must always positive. If let's say I give you example, you have 2 multiply with negative 5. So what you need to do, because MP, this is your MP, cannot negative number, so you need to convert it into negative 5. Negative 2 multiply with 5. So this is the equation or rules for you to remember. Okay, you need to remember this. Example over here, 7 times with minus 5 equal to negative 7 minus multiply with 5. If let's say you have both is negative, of course it's easy for you. You get positive number always. Similar thing when you apply negative value. So there is example here. You need to multiply 2 with negative 7. So this negative 3 negative 3 will be your MC, and MP will be your 2, because it is a positive number. Oh sorry, you will like inverse the negative to be in front. You can also like change it later on, but you need to apply the multiplicand's hardware, which is by changing the sign, not changing the value of numbers. So where is the flow chart for the multiplier? Oh, after that. It's not showing here. Oh, there, this part. Later we go, okay. Now we will like continue with this one. This is under multiplications. Where is it? Where is the example? Forgot already. This one. You can see we have 2 times minus 3, but we need to change the sign. Then we will pick, this is as MP, this is MC. So this is MP, this is MC. And because you can see multiplicand MC, our multiplicand MC is 3, and before this is a minus 3. By using the first version's hardware, because it is negative number before this, that's why you will get okay, this one is our MC, this one is our MP. This is 2, this is 1, you will get 3 as a decimal. But for negative number, that's why you can see you will apply negative value 0, 1. This is 2, positive 2. But because it is negative number, you need to put all 1. As you remember, 0 is represented as positive, 1 equal to negative. That's why you get like this for your MC. And this is your product. First, what you need to check the 0 bits for multiplier. So you have 1, so that's why you will have 1A, which is P equal to P plus MC. This P plus this MC. So you will get this answer. After that, shift left everything. You will get 1, 1, 1, 1, 1, 1, 0, 0. Shift right, this one, 0, 0, 0, 1. And then again, check this bit. Oh, still 1. So you have 1A equal to P plus MC. So what you need to add? You need to add this value and this value. Then you get this P. After that, shift left, 1, 1, 1, 1, 1, 0, 0, 0. This one you will shift right, 0, 0, 0, 0. So how many times? You're going to get until 4 times. Why? Because your multiplier is 4. I think when you have more than 4 bits later on, it's going to be like quite long. So please complete this table also. It is not too hard. Follow the similar step. There is a exercise for you to do. Try to do also these solutions. You can see if your multiplier are having 6 bit. You can see. So you're going to have until 6 times. 6 times, then you're going to stop. So there is exercise also, we can also discuss later on in class, but I hope that you can try, because this one is not too hard, similar also. So before we go to division, I don't want you to confuse, because there is another method for you for division, another flow. So I'm going to stop first this video, later I will continue with division first versions hardware. Okay.